So far, the different arguments that we have been looking at have been very simple. Things like Linda is in this class and has a red convertible, etc. In real life, the kinds of arguments and problems that you as a computer scientist are going to run into are going to be ones that look like the following. So here is a real-world example of a problem that might actually come up in theoretical computer science. In fact, I pulled it directly from an example given in Computer Science 465. For the set cover problem, and you don't have to know what the set cover problem is, this is just simply an example to give you an in real life kind of example. For the set cover problem with n elements, if the optimal solution to this particular problem uses k sets, then the greedy algorithm uses less than or equal to k natural log of n sets right here. So you don't have to understand what a greedy algorithm is or a set cover problem for this introduction to make sense. What I want you to get away from this is the following. We have this statement right here looks vaguely like the kinds of arguments that we have been considering. Indeed, we have an if right here, and we have a then right there. So we have an if-then statement right here. We have some inequalities, and in fact, it is technically possible for you to translate this into propositional logic and then to use our different inference rules to then try to see whether or not this is a valid argument right here. So we have some hypotheses and we have a claim right here. It would technically be possible for you to translate this into propositional logic and then to apply all of our different rules. However, if you were to do that, it would probably take 10 or 20 pages for you to do that. And so what we need to do is we need to collect up a variety of different proof techniques that will allow us to abstract away from the simple inference rules and build more complicated arguments. Similarly to how you don't recreate something like a sorting algorithm in assembly code, you've abstracted that away into a simple little function right here. We're doing the same thing for proofs. We are going to abstract away from simple predicate logic and inference rules, but still leaning on those to introduce different proof techniques, how we could then prove something like this using those proof techniques. So writing down what I just said, we're going to lean on our understanding of logic and inference rules to develop a toolkit of different proof techniques. You can think of these as kind of like helper functions whenever you're trying to write an algorithm.